Hello students. Today we're going to be looking at quadratic equations, and the eventual focus is going to be on intercepts. But first I want us to just look at what a couple of graphs of quadratic equations are. So earlier on in this semester, we graphed things in the form y equals mx plus b. Like y equals 2x minus 3, for example. And these were what we call linear equations, and we knew that the graphs were going to give us lines. In fact, we had 3 different ways to graph a linear equation. We could make a table of values, we could use the intercept method, or we could use slope-intercept form. Today, we're going to be looking at something different. We're going to be graphing equations in the form y equals ax squared plus bx plus c. These are quadratic equations, specifically quadratic equations in 2 variables, because we've got an x and we've got a y. We're going to be spending this lesson and the next lesson examining these graphs. And the first thing that we're going to do is we're going to graph 2 of them using a table of values. We can't use the intercept method, and we can't use slope-intercept form because these aren't linear equations. They're not going to be lines. And those methods only worked when we were graphing lines. So what we need to do is we need to use a table of values. We're going to start by graphing the very most basic quadratic equation that that exists. We're going to start by graphing, we're going to graph y equals x squared. And what we're going to do is we're going to make a table of values with x and y. We're going to pick some positive values for x, 3, 2, 1. We're going to pick 0, and we'll pick some negatives, -1, -2, and -3. Now we know that y is equal to x squared, so always to figure out y, we just have to take x and square it. 3 squared gives us 9, 2 squared gives us 4, 1 squared gives us 1, 0 squared gives us 0, and then remember that when you square a negative, you end up with a positive. -1 squared is +1, -2 squared is +4, and -3 squared is +9. Now what we're going to do is we're going to plot these points on the xy plane and get an idea of what sort of shape this is going to be. All right, so our first point is 3, 9. So we need to go to the right 3 and up 9. 5, 6, 7, 8. 9's going to be just about right there because we really only go up to 8 in this particular template, but we'll go up to 9 there. Now the next one is 2, 4. So we go to the right 2 and up 4. So the next point is going to be there, right here. The third point, 1, 1, is to the right 1 and up 1. It's going to be right there. So we'll draw that in. The fourth point is the origin. That's going to go down here. The fifth point is -1, 1. So we go to the left 1 and up 1. It's going to be right about there. The next point is -2, 4, so that's to the left 2 and up 4. And you're noticing here with these points, instead of going to the right and up, we're going to the left and up. There's actually some symmetry going on. So that last one, -3, 9, to the left 3, up to 9, that's going to be right about there. Now, if we had all the time in the world, we would make a table of values that had 30 different values in it, and we would use fractions and decimals so we could get more points in between all of these to see what's going on. Maybe we're connecting the dots with little line segments. Maybe it's actually crazy and it moves in other directions. But because we don't have an infinite amount of time, I'm just going to tell you that if we were to find more and more solution points here, what we would get is a very smooth curve that goes up in each direction. Now mine is not the absolute smoothest right here. That's because I'm using an Apple Pencil on an iPad and I don't have the same friction that you have when you're writing on a piece of paper. So it's a little bit harder sometimes to make beautiful graphs. Hopefully you like this one. If you want an even more precise one, if you want one that you can explore and play around with, you can actually go to the website desmos.com and you can type in y equals x squared and they will give you a beautifully smooth, clean graph. You can zoom in and out. You can explore it at your own pace. So if you really want to be able to look at this in a little bit more detail, use Desmos and you can get an even better idea. So this is the graph y equals x squared. And this is a very interesting shape. It has a name. This shape is called a parabola. Now, any equation that is a quadratic equation like this is going to give us a graph that's the shape of a parabola. Some of them are going to be skinnier, some of them are going to be wider, some of them are going to be opening downward, they're going to be moved around in different locations, all sorts of other parabolas. And we're going to actually spend a little bit of time later in this semester talking more about parabolas because they have some very interesting reflective properties. If you've ever seen a satellite dish is actually a three-dimensional version of a parabola. But that's something we're going to talk about later. Right now, what I want to do is I want to just look at another one of these quadratic equations. We're going to graph it with a table of values and then figure out what the graph looks like. So let's look at our next example. The next equation we're going to graph is going to be y equals negative 2x squared plus x plus 7. Again, we're going to make a table of values. And if we don't really know what the graph is going to look like, I would always recommend picking x values 3, 2, 1, 0, negative 1, negative 2, and negative 3. Because it's always good to have some positive numbers and some negative numbers as well as 0. And it's easier to have integers instead of fractions or decimals. And usually it's easier to have smaller numbers rather than bigger ones. Because if we took x to be 10, for example, we'd be squaring 10, which gives us 100, and we'd have very large numbers that aren't going to fit on the axes that I've prepared. So we would have to draw new axes, and it's just easier usually if we stick to these numbers. Now, to save time, I'm not going to do all of these calculations with you. I'm going to do one of them. I'm going to plug in x equals 3, and then I'm going to let you pause the video and then do the other calculations yourself, just to save a little bit of time so that this video isn't too long. So let's do one of these together. Let's pick x equals 3. If x equals 3, we can make another column where we're going to show our work. We've got negative 2 times 3 squared plus 3 plus 7. Now, 3 squared is 9. And negative 2 times 9 is negative 18. So that term is going to be negative 18. So we've got negative 18 plus 3 plus 7. Negative 18 plus 3 is negative 15. And then negative 15 plus 7 gives us negative 8. So in the end, we have y equals negative 8. I want you to take a minute, pause the video, and I want you to do all of these calculations but with 2, 1, 0, negative 1, negative 2, and 3. And once you're ready, you can play again, and then I'll give you all of those answers. All right, the rest of the values are going to be 1, 6, 7, 4, -3, and -14. Now let's go through and plot all of these on the xy plane and see what this parabola is going to look like. Okay, our first point is 3, -8, so that is to the right 3 and then down 8. It's going to go right there, right here. Then we've got 2, 1. That's to the right 2 and up 1. It's going to be right about there. The next point is 1, 6. So we go to the right 1 and up 6. It's going to be right there. Then we've got 0, 7. It's going to be up here. The next is -1, 4. So that's to the left 1 and up 4. And then we have -2, -3. That's to the left 2 and down 3. That's going to go right here. And then -3, -14 is actually going to be off the grid. It's to the left 3 and down 14. I could extend my axis all the way down there, but I don't want to. Right now I'm just going to work with these points. And even though they don't look perfectly symmetrical like they were in the last example, this still ends up giving us a parabola. So we can still draw a parabola that goes through all of these points. All right, mine's not perfect here. It's a little wobbly. It should be a beautiful, gorgeous curve. But again, we are not robots, we are people, so we can't have perfection all the time. So this ends up being the parabola that represents y equals -2x squared plus x plus 7. You'll notice this one is opening downwards instead of upwards like the first one. In general, if the leading coefficient is negative, we're going to have a parabola that's opening downwards. And if it's positive, we're going to have one that's opening upwards. So if a is less than 0, if the leading coefficient is negative, it's going to look kind of like a frown because it's sad, because it's negative. And if it's greater than 0, it's going to be opening upward like a smile, like it's positive. Now, we are not going to be using tables of values every time because there are better ways to get more accurate graphs. One of the things on this graph that's not accurate is we don't actually know where the vertex is. It's not actually this point right here, 0, 7. The vertex ends up being a little bit to the right and above this, which I know because I cheated and used a graphing calculator. But when we use a table of values, it doesn't put the vertex in the exact right spot. And the same is true with the intercepts. It doesn't get the intercepts correctly. So in the next video, what we're going to do is we're going to figure out how we can calculate the intercepts to make sure that those points are correct. And then in the next lesson, we're going to be looking at figuring out where the vertex goes. So instead of using a table of values and just hoping that the points end up being nice and giving us an idea of what it looks like, we're going to be going through methodically, figuring out the intercepts, figuring out the vertex, and going from there.